copper deposit at Jerome is a very interesting deposit because it is one of the oldest occurrences of copper in the state of Arizona. In fact, there's only 2 copper areas in Arizona where the coppers are 1.7 billion years old. You know, the other copper deposits in Arizona, all throughout the state, around Tucson and Morenci in the area of Globe, these are copper deposits that are about 50 or 60 million years old. But the deposits at Baghdad and Jerome formed way back in the Precambrian at 1.7 billion years old. And Paul Lindbergh was involved with some of the early studies in the 1970s that determined that this copper was emplaced on the ocean floor 1.7 billion years ago. Now, in 1.7 billion years, you can get a lot of deformation and tectonic crunching that can happen to rocks. In other words, the older the rocks, the more that they've been weathered and deformed. And so it was very difficult for the miners in Jerome to really predict where these copper veins were going. And it was really a source of frustration for the copper miners back in Jerome. So that's a little bit about the Jerome copper. And it's very fortuitous that we were able to see that deposit because the Verde Fault uplifted the Black Hills about 10 million years ago. And that fault just happened to break right where that copper deposit was located. And after the fault exposed the edge of the Black Hills, erosion ate into the copper deposit such that when a Spaniard came through the Verde Valley in 1583, the Indians led him to a place where these blue stones were on the surface. And of course, the Spaniards were not all that interested in copper. It wasn't as valuable as gold. And so they never came back again. But think about it. If that fault had been just a mile or 2 different from where it was, that copper deposit might still be sitting underneath Mingus Mountain. And it makes you wonder, doesn't it? Might there be another copper deposit that exists in these very old rocks beneath Sedona? And that's why all these vortexes are in Sedona.
That's probably a stretch.
Well, it is true. But remember, those Precambrian rocks are deeply buried beneath Sedona and all along the edge of the Mogollon Rim. And I was joking a little bit about the vortexes, but I'm not joking about the fact that there could be submarine volcanic rocks buried beneath the Verde Valley that have these little volcanic areas that are Precambrian in age. It'd be impossible to find them, but then again, we only live in the 21st century, don't we?
Should have a couple more here left to go. Susan Meyer wants to know what causes topographic inversion.
What causes topographic inversion? That's a very good question. I'm glad you asked it. As it relates to the Mogollon Highlands, you know, the highlands were created when the Pacific plate collided with the North American plate, and all along the ancient edge of North America, this mountain range came up. You can think of the Mogollon Highlands in North America to be an ancient equivalent of the Andes Mountains in South America today. Look at the landscape of South America, and what you have is a very steep drop from the Andes down to the Pacific Ocean. And on the east side of the Andes, you have great big rivers like the Amazon draining out to the Atlantic. Well, did you know that 60 million years ago, the Mogollon Highlands were essentially the Andes, and that what we had was a very steep drop down to the Pacific, down on the Yuma side of the Mogollon Highlands. And on our side, I showed you that map with the rivers going across to the northeast. You can think of that as an ancient version of the Amazon River. So when this mountain range was created by compression of 2 colliding plates, it created the Mogollon Highlands, but a different tectonic regime started about 20 million years ago in which those mountains were pulled apart by the tectonic forces that today we call the San Andreas Fault. And what that did is, along with erosion, it destroyed the Mogollon Highlands, and the landscape where they used to be was downfaulted. That's why we drive downhill to Phoenix today. We drive downhill to Phoenix because the crust has been stretched in the last 20 million years, and all these blocks of rock where the mountains used to be have fallen down, and the ancient edge of the Mogollon Rim stands high above it. So that's how topographic inversion occurs in this case.
Okay. Emma Harris wants to thank you for the talk and asks, where were the rim gravel rivers ultimately flowing toward? Lake, ocean,